Okay, so the midpoint approximation to the exponential function that we're working on can be depicted like this. Here's your exponential curve your exponential function. And what you're doing is approximating the area under this curve by two rectangles. The height of each rectangle being the height at the midpoint of the corresponding interval. Okay? So the interval, of course, we're dividing the interval from 0 to 20 into two pieces and doing a trapezoidal and a midpoint approximation. Okay? So the interval from 0 to 10, we're going to base the altitude of a rectangle on the value at the midpoint of that interval, which would be, of course, where x or t, whichever it is, equals 5, right? And then we evaluate at 15 and we get the altitude of another rectangle. And these are just rectangles, right? Now, when we do the trapezoidal approximation, we're actually basing the approximation on the values here, here, and here. And I'll note, just for to get the idea started, that this value and this value only get used once. This value gets used twice in calculating. This value is used in calculating both of these areas. This value only in calculating this. This value only in calculating this. Okay, well, we'll come back to that. Okay, now the main thing, though, is that when you do a trapezoidal approximation, of course, you're doing a straight line approximation. You're using a straight line between the points to define one side of your triangle. And then you're averaging the two values associated with that trapezoid. Did I say triangle?
Yeah.
I think I did. Yeah. We're using the straight line for a side of the trapezoid. Of course, there's a triangle involved if you're trying to calculate slopes, but it's not the trapezoid. Okay. Again, we use a straight line between these points as one side, and then we think of slicing this trapezoid through the midpoint of this segment. And then we get a little triangle up here that we turn upside down, put in this. We could convert it into a rectangle. Okay, that's our basic image of how you get the area of this kind of a graph trapezoid. Well, we see that the value here is greater than the midpoint value. Okay. In yellow, I've got the midpoint value here, and the yellow X here is the midpoint value. Of course, that's the distance between the horizontal axis and the graph at the midpoint of this subinterval, right? And clearly, the graph being concave up, the midpoint value is lower than the value you use in calculating the area of the trapezoid. Okay? And that's true here. So that you would expect the trapezoidal approximation to actually be less than the midpoint approximation here. Is that the way it worked out?
My trapezoid approximation was actually a little bit bigger.
Yeah, that's. I don't think it should have been. So there might have been an error. We'll trace that down in a minute. Okay, I'm sorry. I said it wrong.
Okay, yeah.
Okay, clearly your trapezoid is above, your trapezoidal value here is greater than the midpoint value, so the area of the trapezoid should be greater.
Yeah.
So we figured out where your error was.
Yeah. No way.
Yeah, you didn't make one, I did. Okay. But, right?
Yeah.
Now, if the curve was concave down, then the midpoint value would be above the midpoint of your trapezoidal segment there. So it would be above the average altitude that you use in calculating the trapezoidal approximation. Okay? So there's certainly a difference here. One is an overestimate, one is an underestimate. Now, if you average the two, you're probably going to get a more accurate estimate. We haven't done the integral. It's a very easy integral. You'll be able to do it in a minute. But we're going to do the approximations first, okay? So I didn't ask you to do this. It would have been extra work because you never actually do it, okay? What you do, though, is for reasons that we're not going to develop, we would in a 5-credit calculus, okay? in an engineering calculus course to get the idea. But it turns out that we're going to average these two, but it's going to be a weighted average. Meaning that for one average, you're going to do two of these and average with one of these. Now you don't have to do this twice because you're going to get the same value both times. Okay? But you add two midpoint approximations to a trapezoidal approximation, and then, well, you've added three numbers, you'd better divide by 3, right? Or you add two trapezoidal approximations to one midpoint approximation and divide by 3. Okay? So you're going to calculate weighted 2-to-1 averages both ways. That means you use one of them twice and just one of the other, get the average. Then you use two of the other and one of that one and get the average. And then compare with the actual integral. So, go ahead and do those calculations.